Hello everybody. Today we are going to go over page 5 of your Regents Review packet. Okay, so let's get it going. First one, we've got number 12. We've got this polynomial. It's degree 3, so we know it's going to look something like that or like that. It's going to be one of those wormies, okay? They're going to call it P of x, and we're modeling the volume of a rectangular box here. The graph has x-intercepts, otherwise known as zeros or roots, at -2, 10, and 14. Which statements regarding P of x could be true? So one thing I always push to you guys is you have to know how to take a zero or a root, and you have to be able to turn these into factors. Okay, so we know when we turn these into factors, what we're going to do is we always start with an x, or a variable, but usually an x, and it's degree 3, and we always take that number and we make it opposite. So it's going to be x plus 2, that's a positive 10, so x minus 10, and a positive 14, so x minus 14. We know to change a root to a factor, that process has to happen. So just by looking at that, I know that letter A is not a good answer because they never changed these numbers. Sorry, my daughter is announcing on Alexa. Good Lord, help me, guys. So they did not take these zeros and change them correctly into factors. So I know letter A is not a good answer. So as a good test taker, especially with these A and C, A and D, I hate these questions. As a good test taker, you know that they did this one wrong. So I would go to any one and I would say, oh, number 1, I know it can't be because it has an A. Number 2, can't be because it has an A in it. So that list leaves me to a 50-50 shot of guessing, okay? So I know that B obviously is correct, and look, it's got the correct factors, x plus 2, x minus 10, x minus 14. Notice the leading coefficient here is negative. That tells me that the graph is going to look like this. Okay, it's going to be going down here and down here at the end. So letter B is absolutely correct. So I'm down to C or D. The maximum volume occurs when x is 10. Well, we got a little problem with that statement because what do I know about 10? It's a root or a 0. So I know this is going to hit the x-axis. So at 10, it's going to have a volume of 0. Probably not the maximum volume going on, correct? So the last one, the maximum volume of the box is approximately 56. So what I did is I took this equation and I've already typed it into a graph. Sorry, my lights are weird. I've typed it into a graph, okay? So check this out. Those are going to drive me crazy. Hold on, let me turn those off. There, we'll try that. So here we go, third time, charm. Typed it into a graph. I am going to evaluate it by hitting enter. And it certainly does not look like I told you it was going to look. All right, that's a problem. So a lot of times on this Regents, they're going to give you graphs that you cannot see. So what you have to do is you have to go to Menu, number 4, Windows Zoom, and you have a couple choices. You could either Zoom Fit A or Zoom Out 4. I'm going to do number 4. Okay, the center of my graph is about here, so all I'm going to do is I'm going to click. It zooms it out. Oh, still not there. Click. Closer. I'll put the center up there. Hey, there is my maximum point. So now all I'm going to do is I'm going to find that maximum point. So I'm going to go to Menu. I'm going to go to Trace, number 5, and number 1, Graph Trace. All right, so I'm going to just, it changed it on me. I'm going to scan along. There's my 0. That's definitely not the maximum because the maximum is going to happen about right here. Now, notice no word came up. So if you just hit the up arrow, boom, it'll take you to the maximum. And the maximum is at 12.1, and the maximum is 56.3. So that's why letter D is correct. The maximum volume is approximately 56. There it is. Okay, so I know letter D has to be correct. So answer is 4. B and D. Okay, taking a look at number 13, which expression is equivalent to this? So notice, look at the answers, guys. We've got a plain old polynomial, we have a polynomial, a kind of gross polynomial with a remainder, it appears. A polynomial and a polynomial with a remainder. So the only way you can get something that looks like this is by taking this fraction and dividing it. Okay, so we do not want to factor this one. We want to divide it. And we unfortunately don't want to do synthetic. You could, but there is a step involved that you don't like to do. So because of this factor down here, we're going to long divide it. We got a couple things going on though. So we got 2x minus 1. And notice 4x to the thirds. Do you all remember? Placeholders, no x squareds. There are 9 x's and a constant of -5. Okay, so we're going to long divide this sucker. So first thing, 2x times what is 4x to the third? That would be 2x squared. So I'm going to take this and I'm going to multiply it. 2x squared times 2x is 4x to the third. And 2x squared times -1 is -2x squared. Remember, before we actually do this, we are subtracting these. So I have to subtract that. And when I subtract a negative, it turns to be positive. Those go away. Combine them, we got 2x squared. Bring down my next term. So I do the same thing. 2x times what is 2x squared? Well, x, right? This was positive, so this is positive up here. X times 2x is 2x squared. X times -1 is -x. And again, we're subtracting, so subtract this guy. And when you subtract this, it turns to be positive. Those go away. 9x and x, 10x. Bring down this guy, -5. So we're going to do the same thing. 2x times what is 10x? 5. This is positive because this is positive. 5 times 2x is 10x. 5 times -1 is -5. Before we do anything, remember, we are subtracting. So subtract this guy. Subtract this guy, turns to a plus. Those go away. Those go away. So there is no remainder. So we just have to find 2x squared plus x plus 5 and 2x squared plus x plus 5. Number 1. All right. Number 14. You don't know this yet. This is huge, and it's so easy to do. It's called inverse, okay? To find an inverse of any function, what we're going to do, first of all, we're going to rewrite this guy, okay? Remember, f of x is a fancy way of saying y equals. So that's my first step, x plus 1 over x minus 2. So I write it in terms of y's and x's instead of f of x. To find an inverse, all you're going to do is wherever you see the letter y, you're going to replace it with an x. And wherever you see an x, you're going to replace it with a y. There's an x here, so I'm going to replace it with a y. Okay, that's the inverse. Now notice, that's not over here. So what we have to do is we have to take this now and resolve it for y. So we're going to pop that over a 1, and we're going to cross multiply. So remember, when you multiply that way, you're going to do the distributive property. So we've got xy minus 2x. And when you cross this way, it's just going to equal y plus 1. All right, so if I'm resolving this for y, notice there's a y here, there's a y here. I got to get them together. So I'm going to take away this y over on this side, and I'm going to bring this 2x, add 2x. I'm going to bring that over to this side. So here is the deal. Those are gone, and those are gone. You cannot combine these. These are not like terms. So you have xy minus y equals 1 plus 2x. Okay? Remember, Schneider on your shoulder, guys. There's a GCF here. The GCF is that y that we are so desperately trying to solve for. So when you take that out, you're left with x minus 1 equals 1 plus 2x, okay? So now if you want to get y by itself, you're going to divide this side by x minus 1. And if you do it to that side, do it to that side. So those are gone. So y is 1 plus 2x over x minus 1. The only difference that you guys need to know is that this can be rewritten in function notation as an inverse, and that is f of x, but it's got a little -1 here. That stands for inverse, Okay, so 1 plus 2x over x minus 1. Remember commutative property, yes? 1 plus 2x, 2x plus 1. So that's how you find an inverse. You take the equation, you write it with a y first, and then you take every y, change it to x, take every x, change it to y, and then resolve for y. That's called an inverse. And hopefully we'll get back to school and I can teach you more about those, okay? But for right now, that's what you need to do. There we go. All right, number 15. Which expression has been rewritten correctly to form a true statement? Now, remember my kids that like that calculator trick, you tell your calculator x is 2, and you type this whole thing in, and you're looking for which one says true in your calculator. All right, same thing. X is 2, type this whole thing in. Does it say true or not? X is 2, type it in. Same thing, type it in. You're looking for the one that says true. But what kind of teacher would I be if I didn't do the algebra, right? So here we go. Taking a look at this one. This is actually, it looks really jacked up, but this is actually a trinomial, okay? X plus 2 squared plus 2x plus 2, notice these are the same, minus 8. So it's basically like x squared plus 2x minus 8, except it's not x, it's x plus 2. So that makes it a little bit weird, all right? So what I would do is I would factor this using trinomial. Game on. Okay, here we go. Usually if it's an x squared, we do x and x, but it's not. It's x plus 2 squared. So that is x plus 2 and x plus 2. Okay, so that's a little different. Now we're going to come to the back. We're looking for factors of 8 that have to subtract to be 2. So factors of 8 that subtract to be 2. That would be 4 and 2, yes? Signs are going to be different. Bigger number is going to be positive. So bigger number here is positive. Jeepers. So he's opposite. So all I'm going to do is I'm going to clean this up a little bit. These combine together to give me 6. Ooh, those combine together to be 0. So that's what it turns into. And looky here, x times x plus 6. So I don't have to do any other factoring going on here, which, by the way, you totally could, right? This is a grouping, this is a grouping, and this is another trinomial, okay? But I don't have to go any further because number 1 factored correctly. All right, so there you go. Those are the answers to page 5. If you guys ever have any questions, send me an email, shoot me a message, and I will get back to you ASAP. All right, bye.